The limit as x approaches 0 of the integral of f of x plus h minus the integral of f of x all over h. So when we take the first look, it's like the definition of a derivative, right? So it's very natural to think, why not use it to actually find or solve integrals? Well, first off, let's be very clear, this is not a stupid question. In fact, it shows exactly the kind of thinking you want to have in math. So you're trying to connect something you've already learned, the definition of a derivative, with something new, which is how integrals work. And curiosity is gold, so let's walk through this carefully. What this Reddit user actually wrote is an attempt to differentiate an integral. That is, if you already have an integral of a function, and you want to take the derivative using the definition of an integral, then yes, you will end up with the original function again. This is exactly what the Fundamental Theorem of Calculus says. The derivative of an integral of a function gives you back the original function. But here's the thing, if your goal is to solve or evaluate an integral, you're going to be in the opposite direction. So using a derivative formula to solve an integral is like asking, what's the square root of a number by squaring again? It just takes you right back to where you started. You are undoing the solution, not finding it. So what's the takeaway here? The takeaway is you are not wrong, your question is not stupid. That expression you wrote is completely valid. It's just not a method to solve integrals. It's a method to undo them. And that's why we don't use it to evaluate integrals, because it only works when the integrals have already been solved and you are trying to get the original function back. Derivatives undo integrals. Integrals don't get solved by taking derivatives. And that's it for today. If you've ever stared at a math expression and thought, wait, can I flip this around? Congratulations, you are thinking like a mathematician. There's nothing to be ashamed of. Remember, not everything works in reverse. And as we saw today, trying to solve an integral by taking its derivative just brings you right back to where you started. If this helped to clear things up, give this video a like and hit subscribe. And if you've got more what-if questions like this one, drop them in the comment section and I'd like to explore them with you in the future video. Thank you so much for watching. Namaste.